On a clear autumn day, the powerful Long March 2D rocket stood poised at the Jiuquan Satellite Launch Center, its white body gleaming under the crisp sky. As the countdown reached 0, engines roared to life, and the rocket soared upward, leaving a trail of fire and ambition behind. This mission carried 5 brand-new Shiyan-30 satellites into orbit, each one packed with advanced technology and promise for the future. While such launches have become almost routine for China, this particular event marks another significant leap forward in the nation's ambitious and rapidly evolving space agenda. The Shiyan series, whose name translates to experiment, is designed as a flexible platform for testing cutting-edge technologies and gathering a wide range of scientific data. Each satellite in the series serves as a testbed for innovations that could shape the future of space exploration. Officially, these satellites are tasked with monitoring the space environment, verifying new technologies, and acquiring valuable data from orbit. Their missions are often described in broad terms, reflecting the experimental nature of the program. But this broad description is intentional. It allows for a wide range of missions and experiments to be conducted under a single, non-specific banner, giving China flexibility in its space operations. The 5 Shiyan-30 satellites will operate together as a coordinated constellation, flying in formation to enable more complex and comprehensive observations than any single satellite could achieve on its own. The China Aerospace Science and Technology Corporation, or CASC, confirmed the precise and successful deployment of all 5 satellites into their intended orbits, a testament to the reliability of China's launch systems. This mission highlights a key trend in modern spaceflight, using multiple, smaller satellites working together as a network to provide better coverage, increased data collection, and greater resilience. If one satellite encounters a problem or fails, the others can seamlessly continue the mission, ensuring a steady and uninterrupted flow of critical data back to Earth. For the general public, it may seem like just another rocket launch, but for industry observers and experts, it's a clear sign of China's growing capability to rapidly deploy and manage satellite constellations. This ability to build and expand large-scale satellite networks is crucial for the future of communications, Earth observation, and even national security. The Shiyan-30 mission demonstrates China's advanced capacity in satellite design, manufacturing, and deployment, placing it among the world's leading spacefaring nations. As these satellites begin their operations, they'll contribute to a growing and continuous stream of information, supporting China's expanding space program and its scientific, commercial, and strategic goals. The exact nature and potential applications of the data collected by these satellites remain a subject of global interest and speculation, fueling discussions among scientists, analysts, and policymakers worldwide. With each successful launch, China further cements its presence in low Earth orbit, steadily building a robust infrastructure in space. The Shiyan-30 constellation stands as a clear signal of China's intent to lead in space technology and innovation, showcasing its determination to shape the future of space exploration. The world is watching closely as these experimental satellites begin their work, eager to see what new discoveries and advancements will emerge from China's latest venture into the final frontier. The Shiyan-30 launch is just one example of China's rapidly accelerating space activity. In the past, such launches would have been headline events, but today, they are becoming almost commonplace as China's space program gains momentum. In recent years, China has dramatically increased its launch frequency, making what was once rare, now routine. The country's launch schedule is now packed with missions, sometimes with multiple launches occurring within the same week. In 2024, China conducted a record number of launches, second only to the United States. This surge in activity highlights China's determination to compete at the highest level of global space exploration. This high launch cadence signals a mature, reliable space industry. It demonstrates not only technical capability, but also organizational efficiency and confidence in their systems. Frequent launches allow China to quickly expand and upgrade its space infrastructure, communications, navigation, and Earth observation satellites. This rapid deployment is essential for supporting everything from internet connectivity to disaster monitoring and national security. Each mission also provides opportunities to test new technologies and train personnel, building expertise across the program. These launches serve as real-world classrooms, where engineers and scientists refine their skills and push the boundaries of what's possible. State-owned giants like CASC and CASIC have streamlined rocket production, while commercial companies like Landspace and Galactic Energy are adding to launch capacity. This collaboration between government and private industry is creating a robust ecosystem for innovation. This blend of state and private innovation is fueling China's growth as a space power. The competition and cooperation between these entities drive technological progress and lower costs. Looking ahead, dozens of missions are planned for 2025, from crewed flights to lunar probes. Ambitious projects, such as lunar sample returns and deep space exploration, are on the horizon. This relentless pace is transforming the global space landscape. Other nations are watching closely, as China's advancements set new benchmarks for what's possible in space. China's ability to launch often and reliably is the foundation for its long-term ambitions: satellite mega-constellations, lunar bases, and more. These projects could reshape how humanity uses and explores space in the coming decades. The steady drumbeat of launches is the sound of China's rise in space. Each successful mission builds confidence and inspires the next generation of scientists and engineers. With each mission, China moves closer to its goal of becoming a top-tier space power. The nation's commitment is clear, and its progress is undeniable. The world is taking notice of this new era in space competition. As China's capabilities grow, so does its influence on the future of space exploration and technology. China's launch cadence is now a defining feature of the modern space race, setting the pace for others to follow and shaping the next chapter of humanity's journey beyond Earth. The Shiyan satellite program has a long, enigmatic history, beginning in 2004. Officially, Shiyan satellites are for scientific experiments and technology verification, but their flexible design hints at broader uses. They serve as test beds for technologies that may later be used in military, intelligence, or civil satellites. Shiyan missions have tested advanced sensors, communications links, propulsion, and even signal intelligence equipment. The ambiguous Shiyan label allows China to keep specific capabilities under wraps, a common practice for sensitive space tech. The Shiyan-30 mission, with its 5-satellite network, is a major step in coordinated constellation operations. This requires precise station keeping, data fusion, and robust inter-satellite communication. Lessons learned here will inform future operational constellations, from global internet to military surveillance. The Shiyan program is essentially China's space R&D lab. Technologies proven here often reappear in operational systems. The Shiyan-30 launch is more than an experiment. It's a preview of China's next-generation networked space systems. These advances will enhance China's ability to monitor Earth and project influence from orbit. The world is watching as Shiyan's experimental tech becomes tomorrow's standard. The Shiyan-30 satellites, officially for space environment monitoring, are part of China's expanding Earth observation capabilities. Earth observation satellites are vital for military intelligence, economic planning, and disaster response. They provide persistent global coverage, monitoring troop movements, tracking maritime activity, and assessing natural disasters. High-resolution imagery helps authorities respond quickly to crises, from floods to wildfires. These satellites also support economic goals, monitoring crops, urban growth, and energy infrastructure. By developing its own advanced systems, China reduces reliance on foreign data and positions itself as a global data provider. The Shiyan-30 network may be testing new ways to gather and process this critical information. Constellations allow for frequent revisits, enabling near real-time monitoring of dynamic events. This high revisit rate is crucial for both military and civilian applications. Mastering networked observation gives China a strategic edge, seeing and understanding global events as they unfold. The ability to monitor the planet in near real time is a powerful tool for influence and security. As China's capabilities grow, so does its role in the global space economy. The Shiyan-30 mission is a step toward a future where China is a leader in Earth observation. The implications for global security and commerce are profound. China's journey into space began in the 1950s, a time when the world was gripped by the space race. With initial technical assistance from the Soviet Union, Chinese scientists and engineers took their first steps into rocketry and space technology. However, as political tides shifted, China soon found itself charting its own course, determined to build an independent space program despite limited resources and international isolation. The first major milestone came in 1970 with the successful launch of Dongfang 1, China's very first satellite. This achievement made China the fifth nation in the world to put a satellite into orbit, a moment of immense national pride that was broadcast to millions. Dongfang 1's iconic tune played from space, symbolizing China's arrival on the global stage of space exploration. Progress continued steadily through the following decades. China developed the Long March family of rockets, which became the backbone of its launch capabilities. The country launched a series of scientific and communications satellites, and even pioneered recoverable satellite technology, allowing them to bring scientific payloads safely back to Earth for analysis. Although ambitions for human spaceflight were delayed by political and economic turmoil, the dream was never abandoned. In the 1990s, China revived its crewed space program, leading to the development of the Shenzhou spacecraft and the Tiangong space station modules. These projects marked a new era of technological innovation and international attention. In 2003, Yang Liwei made history as China's first astronaut, or taikonaut, aboard Shenzhou-5. With this mission, China became only the third country, after the Soviet Union and the United States, to independently send a human into orbit, a feat that inspired a new generation of scientists and engineers. Subsequent missions grew in complexity, featuring multi-person crews, the first Chinese spacewalks, and successful orbital dockings with the Tiangong modules. Each mission was a carefully planned step toward establishing a permanent human presence in space. Today, the Tiangong space station orbits Earth, hosting rotating crews of astronauts who conduct cutting-edge scientific research in microgravity. These experiments range from life sciences to materials research, contributing valuable knowledge to humanity's understanding of space. Overseeing these ambitious projects is the China National Space Administration, which now manages a multifaceted program that includes satellite launches, deep space exploration, and international cooperation. China's Chang'e lunar program has achieved remarkable successes, landing rovers on the moon and returning lunar samples to Earth. Meanwhile, the Tianwen-1 mission has explored Mars, sending back valuable data and images from the red planet's surface. From the humble beginnings of a simple broadcast satellite to the construction of a sophisticated permanent space station, China's space program has evolved into a comprehensive scientific and strategic force, with a clear vision for the future. Each mission builds on the achievements of the last, accelerating China's progress and expertise in space technology, and setting new milestones for the nation. Today, China is recognized as a major player in every domain of space exploration, from low Earth orbit to deep space missions, and is increasingly involved in international collaborations. With bold ambitions and a growing list of achievements, China's space program is not only reaching for the stars, it is actively reshaping the future of space exploration for the entire world.